and get started. All right, so So 2.1 is a little bit of a review on functions. And chapter 2, we're going to be doing a lot of graphing in what's known as the Cartesian plane. Who can tell me what these two lines, the horizontal one and the vertical one, are called axes. What should I label them? Yes, Gio.
The bottom is the the horizontal one's the x-axis, and the vertical one's the y-axis.
That's right. And so the horizontal one we label x, the vertical one we label y. Now, just like we talked about this with the number line, it was not arbitrary which direction was positive and which direction was negative. Is it arbitrary on the Cartesian plane? Can we decide? No, we can't. It is fixed. Okay, and the x-axis is just like the number line. In other words, this is the positive direction, and this is the negative direction. I think it's pretty intuitive, but who can tell me on the vertical or y-axis what is positive and what is negative?
Up is positive and down is negative.
That's right. Up is positive and down is negative, and I think that that's pretty intuitive. What do we call the point of intersection at 0, 0?
Origin.
The origin. That's right. So this point right here at 0, 0 is the origin. And when I have a set of numbers like this in parentheses, one and then a comma followed by the second one, what is this referred to as? This group specifically of information in this order.
Sorry, what was the question?
What do we refer to this as? If I have an open parenthesis, a number, a comma, another number, a closed parenthesis, and it's referring to a point somewhere on the plane, what is this grouping called? Coordinates, that's right, very good. So 0, 0 is the origin. Any random, well, not random, but a pair of numbers that's indicating a location on the Cartesian plane, those are its coordinates. All right. And I need one more. Color here. All right, so we have blue and maroon. Are both of these legitimate graphs on a Cartesian plane?
No.
So for those who say no, so I saw you shake your head, Lily. Because why?
Well, I think that one is legitimate. I just don't think the circle is.
Okay, so we have a question. So maroon looks like a legitimate graph. Blue doesn't. Lily.
Because there are multiple outputs for one input.
Okay, so we have this idea of multiple outputs which this has and this doesn't. In other words, if our y is -6, or sorry, our x is -6, we have both, 3 and 9. But does that mean this isn't a graph?
No.
Yes, Cece.
Can you do the domain and range thing where it's all squished up into a little box?
We we will return to domain and range. Yes, those are important vocabulary words. So the fact that this is the distinguishing factor between them. So this has a single output for single input. But that doesn't mean this isn't a graph. Can both of these be represented by an equation?
Yeah.
Yes. So actually, they both are represented by a graph, and they both can be represented by an equation. However, the fact that this has multiple outputs for one input, and this has a single output, means that maroon is what that blue is not.
A function.
A function. Okay? So, is this a legit graph? Yes. Is this a legit equation? Yes. Is this a function? No, it is not. So this really is the definition of a function. What's a way graphically, I will complete this here. So is this a legit graph? Yes. And a legit equation? Yes. And a legit function? Also yes. So this is really the distinction between them. All right, let's say that we wanted a simple graphical tool that would help us to determine whether or not a graph is a function or not. We have a little test that we can perform.
The vertical line test.
That's right. So if you haven't seen the vertical line test before, you just take a vertical line and it's like you scan it across the page. And here with Maroony, our vertical line, our ruler, is never touching the graph in more than one location. So it passes, it's a function. But here when we try and do this with our bluey circle, almost immediately, it's failing the vertical line test. The alarms are going off, the lights are flashing. This is not a function. Okay, so we can see central to the definition of a function are outputs and inputs. Which axis is representative of the inputs? And therefore, outputs are y. That means that this is sometimes called the independent variable, and this is the dependent variable. When we're talking about how fast a car is going or another vehicle, what are the units that we usually use for like a speed limit?
Miles per hour.
Miles per hour. Would it make sense to talk about how fast a car is going in terms of hours per mile? Does time advance based on how many miles down the road a vehicle is gone?
That would be cool, but no.
It would be cool, but the answer is no. In other words, we can see in miles per hour, we don't say hours per mile. There's not like some, I don't know, some big creature that as it walks forward, is it somehow advancing the hours of the clock? So we have a good intuition that some variables are independent and others are dependent. All right, so coming back to your question then, Cece, with input and output, to which does domain and to which does range pertain? Do you remember which goes with which, Cece?
Oh no, I'm gonna get confused.
those are the only two possible options. So if you say that, you're guaranteed to be right. Because
Okay.
one of those will be correct.
Okay, I'm just gonna guess. Is domain X?
Yes.
I
Good guess.
got it!
Excellent. Okay, so domain is all permissible. English peeps, is it an I or an A here?
I think it's right.
I think it's right too.
Can I
but
see
I'm
it
not-
with the A?
Yep.
I think it's an I.
Yeah.
Let's see, does this look like?
Oh yeah, it's I.
Yeah, that doesn't look right. Okay, good. All right, everyone. I get hung up on those sometimes. All right, so domain, all permissible inputs, range is all possible outputs. So when we're talking about functions, we can break down. We'll see. We will see some you'll see some examples in the chapter of cases where these aren't necessarily all real numbers, and you'll get to a lot more of that in pre-calculus. But this should be sufficient for 2.1. I'm gonna need to erase some of this information to move on to the next topic. So if you are taking notes on this right now, I'll give you just another minute to make sure you've got down everything that you need.
It's at times like these where I wish I kept my old notes whenever I missed
Yeah.
the first time.
You know, I've always kept all my notes, but I will say though, very rarely have I actually gone back to them. But there have been some times that I have.
I had this booklet that had all of this and more on a single page.
Oh wow. That now see, having it on a single page as like a cheat sheet, that's really valuable.
Yeah.
That kind of thing you should never throw away.
It was thrown away with a big stack of old papers
I see.
from like 5 years worth of school.
Well, you can make another one now, and then make sure that it goes in a safe place.
I don't think I've wished to keep my math notes, but my Latin notes I have wished I could go back and look at the definition.
Oh yeah.
But then I could just not find it anywhere.
Yes.
The problem with my last notes is that they're either from online school and they were really bad. I didn't really actually have a math binder. Or this year, and I also lost kind of stuff, but this year I kept everything and it worked really well for about half the year. And now my binder is so big that you can't really scroll through it anymore.
Oh. Well, if you got some more binders though, you could split them up. Sometimes they've had like a part 1 and a part 2.
I should do that.
Yeah.
The thing with my old notes is they're either irrelevant now or they're necessary, but I can't read them. Or they're gone. I can't read them because my
Well,
handwriting is too
let me
big.
tell you, all of this is great practice for college. It's like note to self, make sure my notes are legible. Note to self, make sure I keep them in order. Note to self, make sure I have enough binders. You know, developing a good organization system that works for you is so important. Okay, so now we're going to move on to 2.2, which I think predominantly is concerned with the idea of slope, and then 2.3, which is graphing lines. Okay, so when I say the word slope, what comes to mind? And it could be colloquial, it doesn't necessarily have to be mathematical, but when I say the word slope, what do you think of?
Rise over time.
Rise over run, yes.
X cubed minus, wait, I don't remember the order, but like y over y cubed minus y1 over x.
That's right. Okay, so this is good.
Like the steepness of something, I guess.
Yes. I feel like we did look this up one time and now I don't remember because to me it's not intuitive at all. What would be a letter that would make sense to use as the letter that indicates slope?
M.
Wait, no.
What?
That's the
Well,
one.
that's what it
That's
is,
the
but
U.
why does it make
Why
sense?
is it-
Why is it an M?
Didn't we go over this last year?
I feel like we did, but I can't remember.
We did.
It's-
We did.
Sasha.
Sasha-
English and then like kept the letter from a different language. Could they
Yeah,
do
maybe it's
that?
from like Greek or something.
Greek or
We,
Latin or
you
something.
looked it up. You looked it up. We couldn't find anything, but Sasha got like so mad that it was M.
Yeah, so it's M for mad. I guess I'll have to look it up again because clearly I don't recall. But yes, our letter for slope is M. And we'll see if we can figure out why that is. Obviously, I wasn't compelled enough by the answer to that question to remember it, so I'll have to try to figure it out again. So yes, steepness, rise over run. Here this has to do with coordinates. So somebody give me a number for a slope that is reasonably easy to graph. Like
1
please.
over 1.
Okay, that's almost too easy. A slightly more. Don't say pi.
3.
Don't say the square root of 2.
3.
Okay, three is good. 3
Next.
is good.
It's the next best thing to pi.
Right.
2 over 3.
Yes. Okay. So if we're going to start graphing, well, let's go ahead. Slope is something that we use in the equation of a line. Who can tell me what's the most common or familiar or favorite formula that represents the equation of a line?
MX plus B.
Yes. Y equals mx plus b. And so this m is the slope. All right. So Lily has given us 3. What's a reasonable to graph? And keeping in mind some of the space I've already taken up, maybe I'm going to have to move it. But what is, well, all of a sudden this b has entered the picture.
2.
Yeah, so we could say 2. This m, this is the slope. Geo, what is the b?
The y intercept.
Yeah, this is the y intercept. Okay. So now if I'm going to graph this line based on this equation, what's the easiest way to start? What's a good starting place for graphing this line? If I'm going to graph y equals 3x plus 2.
This is what I have forgotten.
Good. Okay, good. So we've gotten to a useful place then. The review is done.
But how you
And then I
graph
was-
it?
Yeah.
Start
Do you
the
go
y
to
intercept,
2
like you
and-
put a little point at.
Sorry.
Yes, all right. I've got Cece and Geo in chorus saying the easiest place to start is at the y-intercept at this 2. And that is correct. And now, Taylor, using what you identified as slope is rise over run, what should well, first of all, how can we rewrite the number 3 as a number that looks like it has a rise over a run?
3 over 1.
Yes,
So you go 3 up and over 1.
that's correct. 3 up and over 1 to the left or to the right?
To the right.
To the right, because it's positive, and this is the positive direction on the x-axis.
I still have to think about that.
Yes, but there we go. So we go up 3, we go over 1. What are the coordinates of this point right here that I just marked? What are the x, y coordinates of that point?
1, 5.
Yeah, 1, 5. 1 because we've gone over 1, and 5 because we started at 2 and we went up 3. And then any 2 points determine a line. And so at this point, we can take a straight edge, and if you don't have a ruler, you can just use the side of another piece of paper or anything that's straight. Because at that point, we can connect these 2 dots and we have correctly graphed this line. I want us to go over, and so obviously, okay, a positive slope is one where it kind of looks like we're going up the hill from left to right. 3 is a positive number. This is a graph of a line with a positive slope. What's the orientation of the graph of a line with a negative slope? Yes. I liked the sound effect that went along with that one, Merlin, but that is correct. A line with a negative slope is going down from left to right. What number falls between positive and negative numbers?
0.
0. So a horizontal line, the slope is 0. If the slope is 0, what's the equation of a horizontal line going to look like? Yeah, just b. If we have y equals mx plus b, and m is 0, what's 0 times anything?
0.
Just 0. So a horizontal line is not going to look like y equals mx plus b because m is 0, and so the x term goes away. The equation of a horizontal line is just going to look like y equals b. It's just going to be a line that's at the y-intercept. Okay, more tricky. What is the slope of a vertical line?
Undefined.
Yeah, and let's take a look at y. All right, if the slope of a line is rise over run, what are we attempting to divide by? If we pick 2 points, let's say we pick this one and this one, and we attempt to divide the rise by the run, what are we attempting to divide by?
0.
0, which we can't do. That's undefined. So vertical line, m is undefined. What's the equation of a vertical line?
X equals something.
Yeah. This is just going to be x is equal to some constant. It doesn't have a slope. It doesn't have a y-intercept. Is a horizontal line a function? Does a horizontal line pass the vertical line test?
Nope.
Yes, it does.
Wait,
Yeah.
what?
Oh, yeah.
Wait, if it's up and down and it goes through and then it's also up and down.
Well, that would be, does a vertical line
Oh!
pass the vertical
I thought you
line
meant
test?
It is the vertical line.
Yes, exactly. Yes, the vertical line perfectly fails the vertical line test. Not only are there multiple outputs, there are infinite outputs.
It's
okay,
hilarious.
It is the vertical
That-
line test.
yes, and it fails it like spectacularly.
Spectacularly.
Exactly, spectacularly. Okay, so vertical line is not a function.
It also never ends.
It never ends. It never ends.
So you can't actually ever say failed. You never, because it never
No,
ended.
that's not how. I don't think that's how it
If it
works.
were,
Yeah, it's just like if we were writing a Star Trek The Next Generation episode, this would be one way that we could potentially, like, foil the, you know, the Borg or the evil computer or whatever.
It's
'Cause
just like
it would-
infinitely worse and worse.
Exactly.
It's not from a paradox.
Yes.
Ask
So,
them to answer the question.
yes. So, there is more information in section 2.3 about how to come up with the equations of lines, how to graph equations of lines. There is more, but this should be enough information to be able to get started and look at the examples, and they should be making sense, okay? Does anybody have any questions about what's up on the board right now? No, okay, so in that case then, I am going to let everybody get to work, and I will be available to answer questions.